here we go. So we're gonna do our 4 steps and see how it works. So again, step 1 is we're going to rewrite the inequality as an equation. Step 2, solve the equation. Step 3, create 3 interval tables. Step 4, choose a test value in each interval to see if it satisfies the inequality. Okay. All right. So here we have x squared is less than or equal to 15 minus 2x. So step 1 says we're going to rewrite this as an equation. So that means we're replacing our inequality with an equal sign. Okay. Step 2 tells us to do what? To solve it, right? So step 2 says you're going to solve this. So in order to solve this, we need to move our C term and our B term. So we're going to subtract 15 and add 2x because in order to solve quadratics, it needs to be equal to 0. So we have x squared plus 2x minus 15 equals 0. You want to keep your A positive?
Oh.
Yeah. You want your A to stay positive. All right, so you're asking yourself what multiplies to give you negative 15, but adds to give you 2. So what 2 numbers multiply to give you negative 15, but add to give you 2? Switch it.
5 and negative.
There we go. My pen did something real weird. So we have x minus 3 times x plus 5 equals 0. So therefore, our solutions would be x equals 3 and x equals negative 5. That's because 3 minus 3 is 0 and negative 5 plus 5 is 0. So we solve. Then step 3 is to create your interval table. Your interval table is saying you're putting your x values on a number line. So I have negative 5 and I have positive 3. And you want to choose a test point to determine whether it's positive or negative. So I like to choose 0 as my test point because if I plug in 0, that's fairly easy to calculate, right? So if I let 0 be a test point and I plug 0 into this, I get a negative 15. Do we see that? So 0 would be negative. So this is a negative number, which means that these are going to be a positive because quadratics either go positive, negative, or negative, positive, negative. So my graph is doing something like this. It's going mew, dipping, mew, coming back up in order to make the quadratic.
That's cool.
Okay. So what it's asking me, it said, when we rewrite this, so instead of the initial here, this has to be equal to 0. So it would be x squared plus 2x minus 15 is less than or equal to 0. So at what point am I less than or equal to 0? Meaning when am I negative or equal to 0? When am I negative? I'm negative between these two, right? That's when I get negative values. You see that?
Yeah.
I'm negative between negative 5 and 3. So my answer would be when x is between negative 5 and 3, or I can write it as an interval, negative 5 to 3. And why am I using brackets? Can someone tell me why I'm using brackets?
Because it is included.
It is included because of that whole equal to, right? It's less than or equal to. So we use brackets instead of parentheses.
Oh.
And that's how you solve it algebraically. So yesterday we talked about getting, writing it as an equation, graphing it in the calculator, finding your x-intercepts. But as you can see, you can be the calculator too. Okay. So again, the steps that we followed. We rewrote the inequality as an equation. We solved the equation. We created 3 intervals table. And we chose a value test in each interval to see if it satisfies the inequality. I could have taken 4 and plugged it in and realized it would have been a positive. But I like to just, if 0 is available, guess what?
Case.
Okay. All right. So this is what it would have looked like if you did the whole interval table. So this is the interval line, which is pretty, not so pretty, right? But here's the table fully out. So on the interval table, you could, we know that we're looking at numbers from -infinity to -5, -5 to 3, 3 to infinity. And a number between -infinity and -5 would be -6. A number between -5 and 3 would be 0. A number between 3 and infinity would be 4. I'm gonna get the same answer, but I'm just showing you for facts so that you can see what I said. That pattern is always gonna exist, right? If the middle is gonna be negative, then the outsides are gonna be positive. If the middle is positive, then the outsides are gonna be negative, so that you can see how that works. So here I have -6, I plug it in and I get a +9. Did we say it would be positive to the left? Yes. We already did 0, so we knew it was negative. I have a +4, I plug it in, and I also get, I get a positive, and we did say it was already positive to the right. So that's just verifying what we did. All right. Okay, that is it for 3.4.